All right, I'm going to do one additional example from section 12.4. I'm going to say 12.4 example 2. Find our our tangential normal components of acceleration and our unit tangent vectors for a three-dimensional vector. So we're going to say for this one, r of t is e to the t sine t I hat plus e to the t cosine t j hat plus e to the t k hat. And we're interested in time t equals 0. And we want to find unit tangent vector, unit normal vector, a tangential component of acceleration, normal component of acceleration at t equals 0. I'll erase this one. We'll be okay without that. All right, so let's take some derivatives. R prime. For our first derivative, we get e to the t cosine t plus e to the t sine t I hat. We're using the product rule. Plus, for our j hat, y component, we get e to the t cosine t minus e to the t sine t j hat plus e to the t k hat. Second derivative, our double prime, our acceleration vector, we get a nice long expression, e to the t cosine t minus e to the t sine t plus e to the t cosine t plus e to the t sine t I hat plus another nice long expression, e to the t cosine t minus e to the t sine t minus e to the t cosine t plus e to the t sine t j hat, and we get a plus e to the t k hat. And I can simplify this, so I'm going to say this simplifies to, after a little bit of work, 2 e to the t cosine t I hat minus 2 e to the t sine t j hat plus e to the t k hat. R prime at the time we're interested in, R prime at 0, is I plus j plus k. Magnitude of R prime at 0, square root of 3. So this will give us our unit tangent vector. Unit tangent vector is square root of 3 over 3, or I'll say 1 over square root of 3 times I hat plus j hat plus k hat. Our double prime at 0 is 2 I hat plus k hat. Magnitude of our double prime at 0, square root of 5. So our tangential component of acceleration is going to be r prime at 0 dot r double prime at 0 over the magnitude of r prime at 0. And for that we get I plus j plus k dot 2I hat plus k hat. We got my dot there. There's my dot. Divided by square root of 3. And when we do our dot product, we get a 2 plus 1, so we get a 3 over the square root of 3, which is just the square root of 3. So there's our tangential component of acceleration. Our normal component of acceleration. A sub n, we could use our cross product, but we have a much nicer formula. Square root of the magnitude of our acceleration at 0 squared minus the tangential component of acceleration at 0 squared. And for that we get the square root of 5 minus 3. So we get the square root of 2. Cross product with these vectors, a little more work, but we would get the same result. And then finally our normal unit normal vector at 0 is going to be the acceleration at 0 minus a sub t at 0 times our unit tangent vector at 0 all over a sub n at 0. So we get 2I hat plus k hat minus square root of 3 times square root of 3 over 3 times I hat plus j hat plus k hat all over square root of 2. And when we simplify that, we end up with square root of 2 over 2 times I hat minus j hat. And that would be our normal component, or sorry, our principal unit normal vector at t equals 0.